Hey guys, in today's math lesson, I'm going to show you how to solve and graph inequalities. So for the most part, inequality solving is very similar to equation solving, except for one big difference that I'm going to go through in the second example, all right? So in this first example, 3x plus 4 is less than or equal to 10. I'm trying to get that variable x by itself, isolated, just like I am when I'm solving an equation. So if that was an equal sign instead of a less than or equal to sign, we'd be trying to isolate that x by first getting rid of the constant and doing the inverse operation. Same thing happens here. I'm going to do the inverse operation of the constant, which is minus 4, and I'm going to do it on both sides, okay? Instead of both sides of the equal sign right now, it's both sides of the inequality sign. So why did I do that inverse operation? Because 4 minus 4 is 0, and 3x plus 0 is just 3x. So I'm one step closer to getting that x by itself. I'm going to bring down that less than or equal to sign, and I'm going to subtract to get me 6, all right? Now, x is almost isolated, but it still has that 3 as a coefficient. So 3 is being multiplied by the x. So I'm going to do the inverse operation, which is to divide. So I'm going to divide by 3. And just like an equation, whatever you do to one side, you have to do to the other side. So I'm dividing by 3 on both sides. On the left side, 3 divided by 3 cancels out because it's equal to 1, and 1 times x is just x. And now my x is isolated. I bring down that less than or equal to sign, and I divide on the right. 6 divided by 3 is 2. And here is the solution of my inequality. X is less than or equal to 2. That means that any number that is less than 2 or equal to 2 will make this inequality true, all right? So if you pick any negative number, or you pick 1 or 1.5, all those numbers, when I substitute them in for x, will make it true. So unlike an equation, there's infinitely many solutions here. There isn't just one value that's going to make this true, all right? So now to graph it, I'm going to go to my number line, and the first thing I'm going to do is decide what type of circle to put on the 2 itself. So because our inequality symbol has this underline right here, that means or equal to, that means that when I go to the value of 2, I'm going to put a shaded circle there. That shows me that the value 2 is included in my solution. Whereas if my answer was x is less than 2, then I would have to just put, I'll just draw a little one here, I would have to put an open circle on 2 to show me that that's where it's going to start, but the 2 is not included, okay? But in the inequality that we have, 2 is included, and so we are putting a closed circle on there, all right? And now I want to show that also, in addition to 2, all the numbers less than 2 work. And I'm going to show that by shading this entire number line, including the arrow, to show that all of these numbers to the left of 2 are part of my solution set. So every number in that blue, including the numbers I can't see that go on to the left, are part of the solution set, okay? The easy way to remember which way to graph is if your variable is on the left, you can kind of just think of this inequality symbol as an arrow showing me I'm supposed to be going left. All right, let's do another example so you guys can see one of the big differences that happens when I am solving inequalities versus equations. So again, trying to get x by itself, right? So again, I want to get rid of that constant first. So I'm going to go minus 7 on both sides. That will get rid of the 7 on the left, and then I am bringing down a minus 3x, right? Don't forget the symbol before it has to come with it, is greater than 12. Now, to get rid of that negative 3, I have to do the inverse operation, which is to divide by negative 3. However, as soon as you divide by a negative number, this is where fireworks needs to start going off, because this is the major difference. When you multiply or divide an inequality by a negative number, you have to flip that inequality symbol around. So what was a greater than sign is now actually going to become a less than sign. This only happens when you multiply or divide by a negative number like we just did, all right? So on the left side, negative 3 divided by negative 3 gives me 1. So I'm just left with x, because 1x is the same as x. And on the right side, I have 12 divided by negative 3, which is negative 4. So my solution here is x is less than negative 4. Because I don't have that or equal to sign, that means that negative 4 is not part of my solution. So when I go to graph this, I need an open circle on negative 4, showing me that's where it starts, but negative 4 is not part of the solution. It's not going to work. And then I also want to show all the numbers that are less than negative 4, And those are the numbers that are to the left, right? Further away from zero are going to be the numbers that are less than -4. So this would be the appropriate graph for the solution set of x is less than -4.